Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have m to the power of 9 is equal to 13 to the power of m. Now for this solution, alright, so we're first starting with m to the power of 9 is equal to 13 to the power of m. Now what I'm going to do is I'm going to take the ln on both sides. So now I have ln of m to the power of 9, and now this is equal to ln of 13 to the power of m. Now an important property of logarithms is that, let's say I have log a to the power of b. I can actually move this exponent b to the front of the logarithm. So this would equal b times log a. And this property is known as the power property. And because ln, the natural log, that's also a logarithm. Meaning if I have ln to the power of a to the power of b, this is equal to, I can move my exponent, b times ln a. So in this case, I have ln m to the power of 9, and this is equal to ln 13 to the power of m. So I can think of m as a and 9 as b. So I can move this exponent 9 to the front of the logarithm. So this would be 9 times ln m, which is equal to ln 13 to the power of m. And now I'm going to do the same thing with ln 13 to the power of m. I'm going to move my exponent to the front. So now I have 9 times ln m is equal to m times ln 13. Now what I'm going to do is I'm going to divide both sides by 9m. So then these two would cancel out, and I would be left with ln m over m is equal to, these two would cancel out, so ln 13 over 9. Now, if I have something in the form, now if I have e to the power of ln of x, this is actually equal to x, because the e's and ln's cancel out. So m here, e to the power of ln m, this is equal to m. So now I have ln m over e to the power of ln m is equal to ln 13 over 9. Now I have ln m times e to the power of negative ln m is equal to ln 13 over 9. Because a negative exponent, let's say I have a to the power of negative m, this is equal to 1 over a to the power of m. So now what I'm going to do is I'm going to, from ln m times e to the power of negative ln m, this is equal to ln 13 over 9. Now what I'm going to do is, so now to solve this, what I'm going to use is the Lambert W function. And what the Lambert W function is it states that if I take the w, if I take the w of a times e to the power of a, this is simply equal to a. So I'm going to be using this Lambert W function on our equation here. So our equation is ln times m times e to the power of negative ln m is equal to ln 13 over 9. So now if I use this function, and now before doing that, if I multiply both sides by negative, I get negative ln m is equal to negative ln 13 over 9. So now if I take the Lambert function, I get w of negative ln m times e to the power of negative ln m. And then what I have to do on one side, I have to do on the other. So this is equal to w of negative ln 13 over 9. Now this is equal to negative ln m, which is equal to still w of negative ln 13 over 9. And now if I have something in the form log a to the power of negative 1, this is equal to negative log a, because I can move my exponent here to the front. So this negative I can move to the front. So now I have ln m to the power of negative 1 is equal to w of negative ln 13 over 9. Now if I take e on both sides, I get e to the power of ln m to the power of negative 1 is equal to e to the power of w of negative ln 13 over 9. So then this e and ln cancel out. So now I would be left with m to the power of negative 1 is equal to e to the power of w of negative ln 13 over 9. Now m to the power of negative 1 is the same thing as 1 over m. So I have 1 over m is equal to e to the power of w of negative ln 13 over 9. And now 1 over m is the same thing as, now if I replace these two, I get 1 over e to the power of w of negative ln 13 over 9 is equal to m. So that is our answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this problem without a calculator. So we have 6 to the power of 6 plus 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 6 to the power of 6. Now, because all of these terms are the same, I'm actually just going to factor out 6 to the power of 6. So if I factor out 6 to the power of 6, I get 6 to the power of 6 times, now 6 to the power of 6 divided by 6 to the power of 6 is 1 plus same thing, 1 plus same thing once again, 1 plus 1 plus 1, finally plus 1. So now we have 6 to the power of 6 times 1 plus 1 plus 1 plus 1 plus 1 plus 1. Now let's simplify what's in the parentheses. The sum of all these ones is 6. So now we have 6 to the power of 6 times 6. And whenever we're multiplying exponents, let's say we have a to the power of m times a to the power of n. All we do is we simply keep the base the same and we add the exponents. So this would be a to the power of n plus n. Now for 6 to the power of 6 times 6, well 6 is the same thing as 6 to the power of 1. So this is going to be 6, because we keep the base the same, to the power of 6 plus 1. And 6 plus 1 is 7, so this is equal to 6 to the power of 7. Now, an easier way to do it is, instead of factoring out 6 to the power of 6 in the beginning, well, you can already see that there are 6 to the power of 6's, right? So that would just be 6 to the power of 6 times 6. And then 6 to the power of 6 times 6 to the power of 1, well, we already did this. This would be 6 to the power of 7. So that's just a faster way of doing it instead of factoring it and doing all of that.